Now, I trust you read the chapter that talks about barcoding and understood the thing that you didn't have to learn how they do it in America using the system that's in the book, that instead I'm going to supplement the EAN13 method. The EAN13 really is just, well, that's supposed to be EAN-13. It's what is used in Europe and, of course, in Lithuania. And so you'll see this kind of barcode. It has 13 digits when you look at this. This last one I have hidden because we're going to figure out what it is. But there would be 13 of them here, including this one I have covered. And it is what is used. As you know, there are many different kinds of barcodes, but if you go to Maxima or an IKI, most things you would buy in there have the EAN13 barcode system. So it's the one that I will want you to be aware of, and you can figure you're going to see this kind of thing on at least the exam, possibly a quiz. So being able to figure out what the check digit is is helpful. Now, just for your review, if you had this before, you know that the first 2 or 3 digits are the country code. For example, 477 represents Lithuania. The next digits identifies the manufacturer. If the first one was 2, the next 5 do, or if the country was 3 long, then the next 4 represent the manufacturer. So in Lithuania, the 477 would be this, so the manufacturer is just 4 long. So that would be like if you're finding from Lithuania, Klaipėda Duona. That would be the manufacturer. The next 5 digits are the product, and that could be something as, say, their Batonis product. So this 30, well, of course, this is not Klaipėda Duona, but if it was, this would represent Klaipėda Duona. And the last one is a check digit. The book explained what that is, so I won't say much more than it's how they know that the barcode is correct and that everything has worked out, and how the computer knows that it did not misscan a product. The book explains it in more detail and better too. Now with the EAN13 barcode system, it's different than what is in the book, using the UPC system of America. With the EAN13 system, all of the odd positioned values, you add just that value. Now that doesn't mean that the odd numbers. It simply means the ones that are in the odd position. The odd positions, of course, would be that this is the first one, so we're just going to add 5, have a running total. This is the second one. Even though it's odd, it's the even position. 2 is even, so we do something else with that. 0, even though that's even, we're just simply going to add 0. Down here, we're just going to keep a running tally of all of the values. The 5th position, and the 7th, the 9th, the 11th, and the 13th. So we're just going to add 9, add 2, add 0, add 0. We don't know what this value is. Again, I hidden it so we can figure out what it is using the check digit. So we'd simply say, well, this is plus X. It's some value. Whoops, I'm realizing you can't see that there. So yes, all I did was, for these ones, just wrote down the totals there. Now for the in-between ones, or the even ones, with the even positioned values, you multiply them by 3 and then add that total. So in this case, here we can see it again, I'm going to take the 9 and I'm going to multiply it by 3. The 0 times 3, the 4 times 3, the 3 times 3, the 4 times 3, and the 0 times 3. Now that total I'm going to put down here. So 9 times 3, I'm going to add 27. 0 times 3, I'm going to add 0. One common mistake that's easy to make when you're in a hurry because, oh, I just got to do this so many times and it's not hard. Students look at this and say, oh, this is 3. And of course they get a wrong answer. 0 times 3, it's just something to watch, that you get 0 when you multiply 0 by anything. This is plus 12. 3 times 3 is plus 9. 4 times 3 is plus 12. 0 times 3, again, plus 0. So we're going to make a total of all of these. And you can use your calculator. But you end up with 76 when you add up all of these, plus x for the x over here. Now, like the UPC system, if you read the book, whatever this is, this whole thing, this 76 plus x, when you do mod 10 to it, whatever this is equal to, it's going to be equivalent to 0 when you're doing mod 10. Excuse me. So if this is the case, 76 plus x has to be equivalent to 0 when doing mod 10. When you look at it, to get 0 when you're doing, actually that's not a good way to write that, 0 when you're doing mod 10, well, what numbers would give you that? Well, of course, the multiples of 10. 0 would do it. If you do 10 mod 10, you get 0. It'll have to be plus here. Also, all of the multiples of 10, 30, 40, 50, 60, 70, 80, 90, 100, 10, and the list continues on. Now, when we're doing this, however, we want to find the next closest number that when you do modulo to it, you get, when you're doing mod 10, you get 0. So obviously we can't do 70 for it, or any number less than 70, because it's already over 70. We have to add a positive value to this. So 0 through 70 we can't use. So we want to use any of the numbers greater than the number that we have plus x. Well, with that we can just simply start with the very first one, 80. Well, 76 plus x, well, that equals 80 if, that's a plus sign, if x is equal to 80 minus 76, or 4. Now, that actually works. 80, if we take 80 and do, if we take 80 and do mod 3 to it, and say it's mod 10, well, it's 8 times around the clock with no remainder. So it is equal to 0 when you're doing mod 10. So then that tells us our value of x is 4. So back up here we could put in and say that this is a 4. And that is correct with this. Now, the other thing that is possible when you're doing this is that, let's say, again, we know this is a 4, but what if we didn't know this 9 instead? So the 9 was covered up. Well, we go through this same thing, but now this time, this is simply going to be x times 3. So instead of 27, it's going to be 3x. And now this one is going to, instead of be x, it's going to be, lost my camera there, hang on a sec. Sorry about that. Yeah, so this is now x, so we end up x times 3 is 3x. And this 4, simply we're going to add 4. When we do our new total of all the numbers, well, then we end up with here we go. 53 plus 3x now, instead of the x, because it's in an even position. But this also has to be equivalent to 0 when doing mod 10. So we can go back to our list and say, well, okay, now since it's 53, the next higher number starting with 60. So we say, well, let's try that. 53 plus 3x equal to 60. Well, 3x is equal to 7. X is going to be equal to 7 over 3. Well, that's a problem, right? Yeah, of course. The value for x has to be a number, not a fraction. So in this case, going up to the next power of 10 didn't work. So we can say this one didn't work. Now, we would continue on. 60 didn't work, so we go up to the next multiple of 10, which is of course 70. And we say that 53 plus 3x is equal to 70. As we try to solve for x, we get 3x is equal to 17. So x is equal to 17 over 3. Now, again, that's going to be a fraction, and it has to be a natural number. So, or actually, it has to be a whole number. So we say, well, again, this one didn't work. Well, then again, the next thing we can do is go out and say that 53 plus 3x is equal to the next multiple of 10, which is 80. And if that's the case, 3x is going to equal 27. And of course, we can divide 27 by 3 nicely and get 9. So our next value, our x value has to be 9. And of course, when we go back up here, we know that that is the case since we scribbled it out. So when you're doing it barcodes and it's an even position one, you have to use the second way of doing it. But the concept is similar, it's just a step harder. Now, the last thing that would go over is, again, using the same barcode. That's the official method and oftentimes the correct way, so to speak, of calculating it. But if you thought about it, there is another option for solving this. And for this second option, it's using the same thing, but some students think it's just a little bit easier. Again, all of the odd positioned values, you still just add them. Now for the even positioned, what you do then is add them together and take the total and multiply it by 3. Oops, there we go. Total and multiply it by 3. Now, since we've done this before, save a little bit of time. If we go through and add all of the odd positioned ones together, we had the information from before, so I'm not going to draw it again. But all the odd positioned ones become 16 plus x. When we look at the even positioned ones, we're going to add them up, and all of them together equal 20. We take that total and multiply it by 3. Not the total of everything, but just the total of the even positioned ones. And we end up with 60. Now, we add these together, the 16 plus x plus 60, and we get 76. Now, well, excuse me, plus x. 16 and 60 is 76. The x, of course, stays itself. So now the process is exactly like we did before. This has to be equivalent to 0 when doing mod 10. So you go through and do things exactly the same way as we did before. If, again, the 9 was out, we'd end up with, in this case, if this was 4, we'd end up with 20, and this would be 20. This would be less, and you still multiply it by 3, but then it's going to be also 3x because everything's multiplied by 3. For example, if the total was, let's just say 10 plus x, then it would be 30 plus 3x. Again, it's not the case in this case, but that's how you would do it. If you have any questions, feel free to email me.